Alrighty, gang. So hopefully you've taken another programming course or have some programming experience by the time you get to a 1700 level class. So I don't want to spend an overly long amount of time telling you the difference between an integer and a floating point number, right? Stuff like that. So we will see what Chapter 1 has available for us. So all I did is I went into Canvas, logged into modules. I'm sure you all know how to do this, and I found the PowerPoint section. Whenever you get into Canvas and it's showing a preview, especially of a multi-page, 44-page PowerPoint, it's a better idea to download it and to let your machine's, default viewer view it, get full page and all that. And sure, yeah, you could try to simulate full page with that, but generally better to view it with the operating system's default app unless it just doesn't work. Alrighty, so what's the big deal about C#? Well, in the 90s, Java was a thing. I mean, it still is, but it was a brand new thing. And Microsoft adopted it, they added support for it into their structures, and then they extended it with a whole bunch of extra functionality. And that's what Microsoft loves to do, so that if you want to use their Java programs, you'd have to do it on Windows. And the owner of the Java copyrights and stuff like that said, no, you can't do that. And so that was Sun Microsystems. So Microsoft said, well, fine, we'll make our own equivalent. The syntax for this is rather similar to Java. For one thing, that'd be expected because C++, and Java have a similar syntax. But just like in Java, everything has to be in a class. In C++, you can just throw things into functions and you can start doing some procedural programming. C# is object-oriented from the ground up. And it has some things that are, it's missing some things that you'd find in C++, like pointers. Pointers are inherently risky. They can cause a program to crash because you're modifying memory directly. So C# just rules that out. C# is part of the .NET family. .NET family is where a whole bunch of different languages can be compiled into modules that can be interused among each other. So they all share a certain, function, file, class format underneath it all when it compiles. And they all share certain data types. They all agree on exactly what a double is versus a float versus an unsigned blah, blah, blah. So our goal, we're going to learn about programming. We're going to learn about procedural and object-oriented programming. We're going to learn about C#. And we're going to write a C# program that produces output. And we're going to learn how to select identifiers to use. Okay, what is an identifier? It's just a variable. So when you install Visual Studio, if you have done so by now, you probably got the 2019 version. Well, guess what we're using on the computers in this classroom? Not quite 2019, it's 2013. 2019 looks rather similar, but there's a few key differences, especially in starting up. At least the community version. I need to reinstall and get the professional version and see if it looks a little bit more like this. Specifically, when you go to do a file new project, it just flat out looks different under Visual Studio 2019 than it does in 2013. So I better go back to my 2019 machine and record like a 2-minute video about how to create a project. So if you're stuck and you start watching this and you just cannot figure out how to create a project, either Google up how to create C# console app. Let's go ahead and create some notes, or to watch the video that I'm going to be posting in a little bit. Alright, so you can Google creating a C# console app with Visual Studio 2019 and you'll find tutorials and whatever. Should only take me a few minutes to record that video, so when I get back downstairs I'll try to do that. Anyways, I bet you can figure it out. What am I going to do? I'm going to do File, New, Project. And it needs to be a C# project. So hopefully you chose C# as among your install options. And specifically, I want it to be a console application, meaning it just runs in, good old black and white text window. And I feel like giving it a better name than console application 1. I could call it Lecture A because I enumerate my lectures, if you've taken my classes before, by letter rather than number so that we can distinguish them from homework assignments. Homework 1, Homework 2, Homework 3, Lecture A, Lecture B, Lecture C. It's fun if we've gotten past 26 lectures, and so we're past Z, but we probably won't do that, even if we do 2 a week. We'll see. All right. You could tack your initials onto that, right? If you felt like it. Don't got to do that. You might take note of where it's about to be stored. By default, every semester when I come in, it's trying to create my projects in a location down in the admin directory, which of course fails. So I then have to browse and pick somewhere else. You can let it default to wherever you want, right? You just have to take note of it, because when you go to find your source code to upload it, you're going to want to go there. So what do I want you to upload at the end of semesters? Why are there, at the end of the lecture. Why are there so many? Can I possibly shrink that down so that I get more of my icons on here? That seems different somehow. All right. So anyways, if you want to, while watching the lectures, follow along, type in code. You don't gotta. When done with the lecture, fill out the video review form. Also, upload your .cs file or a zip of the project folder. We'll give an example of all that. So this is slightly different here. If you've taken my classes before, I haven't made you do a video review form. It was an option. But what I figured out is that people would just go into the notes and they would copy and paste the lecture notes into a file and upload it without having watched the video. So I really want you to watch the videos. So that is now mandatory. So that's what you need to do when you're doing lectures. For homework, you don't have to fill out a video review form, right? But for homework, you're going to upload the .cs or a zip of the project. Also, I want you to take a screenshot. We'll cover doing a screenshot. You probably know how to do it. There's 20 different ways to do it on every operating system. I'm only going to show you one. It's just one that makes sense to me. It's available for a lot of different versions of Windows. Okay. You're probably familiar with all this if you've had my classes, but there's some who have not. So let's get to it. I've launched Visual Studio. I've chosen to make a console app, and I'm going to choose OK. Ooh, the project directory already exists. That's because I used a Lecture A and another one. Alrighty, so I'm going to do the lecture, what is our class name? Well, I'm going to just call it CS for C#, right? Lecture C# A. You won't have that problem. Well, maybe you will, because, you may also have C++ projects you're creating or whatever, also called Lecture A. Okay, so when it loads up, it goes ahead and creates a boilerplate for you, which is nice because if you've been doing the C++ programming under Visual Studio, creating an empty project, you had to put the boilerplate in yourself. It includes a whole bunch of imports, although here they're called using. We don't necessarily need all those, but I'm not going to bother to delete them. And depending upon your version, they may be different. That's okay. So, just like in Java, and if you say, well, I haven't taken Java, that's okay. Everything is inside a class. Notice that in this case, I created the project and it gave me the name program.cs as the name of my class. If you don't like that, you can change it. You can rename that. I don't particularly recall if there's a refactor option right here. Yeah. So where it says class program, I could highlight that. You don't got to do this. And do refactor rename. And I could call it Lecture A. Or, if there's a more specific name that makes sense, right, you could rename it to that. It will rename the file and it will modify that statement. If you just go over here, and rename it that way, or you go to Windows and rename it, then, it's not going to work. This needs to match that. Just like in Java, your class name and your file name need to match. So I could call it Lecture A if you feel like it, do it. All right. Notice there's a namespace. In this language, unlike Java, for example, every class you make is enclosed in a namespace. What does that mean? That means you could create multiple classes, multiple files that have the same file name. Excuse me, the same class name in it. I think I just contradicted myself, but we're going to roll with it. So I could have another class called Lecture A in a different namespace. The namespace seems to be named after the project name. We'll play with multiple files with the same class later, just for funsies. I don't normally do that. Usually I give each class a unique name. And so we have a main method. You would call it a main function in C++. It can accept command line arguments. Probably not going to use command line arguments. Maybe we'll demonstrate it once, just because we tend to run it from within, Visual Studio. We click the run button. We're not going to a command prompt and typing, my file -a whatever my parameter lists are. But it's just an array of strings, and you parse it. If the array of strings, has parameters, you could process them. If it doesn't, you could leave them alone. Well, we're certainly going to leave them alone for now. So we're going to improve programs by adding comments and using the system namespace. We're going to write and compile a C# program using the command prompt and using Visual Studio. Well, honestly, we'll just use Visual Studio. So we know what hardware is. We know what software is. We may know that ultimately it doesn't run our code. Instead, it runs a series of zeros and ones which express, which are opcodes for the specific chip. So if you're writing C++, it gets compiled to an executable file that contains all the opcodes necessary to run your chip. C#'s a little bit different. It compiles to something else. It compiles to an intermediate level language, a very low level language, but it's not assembler and it's not machine language, and then that gets turned into zeros and ones, when it gets executed via a runtime engine. So a high-level language is one that uses reasonable keywords as read, write, or add instead of, all right, so like if we go here and we Googled up, hello world 8086 assembler, right, just like we would have written hello world back in the early 80s. Here's what hello world looks like. It's supposed to print a message. Ooh boy, I wouldn't want to program in this, right? Move that. Move that, do that, do that, do that. Here's our message. Nah. Fortunately, we have words like print, right? Read, add. Just because I'm flipping past these fast doesn't mean that I want you to skip reading the chapter or skip reading the PowerPoint. It just means that I'm not going to read every page of the PowerPoint to you. So this textbook recommends that you use so-called Camel Casing for your variable names and Pascal Casing for your methods. Well, what's Camel Casing? Camel Casing actually looks like this. Starts at a lowercase initial letter, and then it has uppercase letters in the middle, right? So user password, right? Something like that. And if you had extra words to add, you'd keep doing that. Pascal Casing, same thing, except it begins with an uppercase letter. Class names also are done with an uppercase letter at the beginning. At least common industry parlance. Don't recall if this textbook enforces that. If we go and look at our source code, we'll see that that's the case, though. Main in C++ and in Java would have been lowercase, but again, they're following the so-called Pascal casing, making them uppercase. Now, I may accidentally make all of my methods lowercase just because that's the standard for a lot of other platforms like Java. Doesn't really matter, it'll run either way. So this language is object-oriented, meaning that it uses classes and objects. What is an object? What is a class? Well, an object, I'm going to define it, is a collection of data, variables, and the methods, functions, except we're never going to call them functions unless I goof up, that act on the data. And then the class is the blueprint for the objects. So instead, I'm going to rewrite this to say that a class is the blueprint for a collection. So I'm just going to copy and paste all that. There we go. That's what I'm going to say, classes. Why don't I make this text a little bit larger? So a class is a blueprint for a collection of data and the methods that act on the data. Now that doesn't mean every class has to have data or every class has to have functions, but in general. And an object is a instance of a class. What is an instance? Say you have a house blueprint. My house plans equals a blueprint equals a class. And then the object, the house I build, or that I hire my contractors to build most likely, is an object. Now typically if we create an object and then we assign it to a variable, we call that variable the object. But the variable isn't the object, it's a reference to the object. Just like if you say, well, I live at 123 South Main. No, you don't. You live at a house and there's an address that points to that house. And the address is 123 South Main. So the address is not the house itself. The variable is not the object itself. You can have two references to the same object, just like you could have two street signs for the same street. So an object is an instance of a class. It's got its own attribute values called the properties of the object. You have a student object, and the student may have a first name and a last name and an age or a birth date, and then there may be a different student object with a different first name and a different last name and a different age contained in it. So those are called properties. Another textbook would call it the state of the object. So encapsulation is when you put all the variables in an object and then you give it methods and it's treated as a cohesive unit. So you might have an employee object and then you might have methods that act upon it. Save to file, right? Fire the employee, reassign them to a new, to a new division, that kind of thing. And that can be called a black box method. You get to pick which methods, which behaviors a programmer using your object is allowed to call. And the interface is the interaction between the methods and the object's exposed behaviors. Uses message passing to request and receive information. Well, this is all a little bit, I just pretty much want to get to the sample code. More features of object-oriented programming languages. They give you inheritance, which is the ability to make a class that extends the ability of another class. So you can have a mammal class, and then a dog is a more specific kind of mammal with more attributes. So you can create a dog class that extends the mammal class, and then specific breeds of dogs, right, have more specific attributes even than that. So you could have a German Shepherd class, which extends the dog class, which extends, the animal class. Since we're going to be hitting these concepts again in later chapters, I don't mind just kind of clicking through them. So here's our first class, if we so wanted to do it, if we'd created it and we'd called it first class. This is how you print. Oh, for the good old days of Python when we just did print parentheses. We get to type all that. Now there's a keyboard shortcut in Visual Studio for doing system.console.writeLine? I'm not sure if I remember it. I'm going to see if I can remember it. SCW tab. Nope, that didn't do it. All right, I'll look it up. Anyways, this is a print statement. System.console.writeLine. And you can print something out. Or if you leave off the word line, it'll display it but will not go to the next line afterwards. Yeah, we may as well add that to our code. I'd also like for us to add a comment block up at the very top, right? I'd put your name there, not my name, right? And this is Lecture A, you know, first program. Could even include the date if you wanted to. All right, we're going to do a system.console.writeLine. Go back. System dot, and notice that Visual Studio is trying real hard to help. It's popping up this so-called IntelliSense thing, so you can just type the first few letters and maybe pick it. It's not system.out, that's Java. System.console. Sorry, I was just doing Java a minute ago. Console. See what I did? I highlighted the right one and then just hit enter. .write, or WriteLine, parentheses, hello, space, end quote, end parentheses. Now, since I just chose write rather than WriteLine, it's not going to print a carriage return. So I might want to print another one out, you know, so it'll actually go to the next line. The reason I did that is just so I could tack on another system.console.write and have it print something else, right? System.console.write, parentheses, you know, friend. But I'm going to make this one WriteLine, so it'll go to the next line, just like hitting enter on your keyboard. So instead of write, it's going to be WriteLine. Yes, sir.
Do you have to use system before the console? Does that matter?
Well, let's find out. If we use WriteLine,
or just like the console.write instead of just.
Can we get away with just doing console.write?
That's what I've been doing the whole time.
Okay, that's cool. The reason we can do that is because we have this using namespace up there. Very good point. I can leave out system because I've got using system up here. It's possible that I could do using system.console. No, that's not going to work. Anyways, good point. I could, since if you tack that on up there, if it's not already there, and it should be, we could leave off the system dots and just make it console and save ourselves some typing. I like that idea. Saving typing is good. On the other hand, it can be, nah, won't even talk about that. Okay, so there we go. There's our code. I'm going to build it and run it. Usually I just wail on the start button, but I feel like building it as a separate step right now for some reason. Build, rebuild solution. I can go to my output, which is kind of hidden down here. 1 succeeded, 0 failed, 0 skipped. What if I had a problem? Like say I had accidentally put a comma here when I shouldn't. Don't do that, I'm just demonstrating. Then when I built the solution, I'd get my error list, argument missing. I could double click on it and it would take me directly there. Now quite often you'll see about 70 errors listed. Don't panic. Your program doesn't really have 70 problems. If you correct like 2 or 3 of them, they'll probably all go away. It's just that once there's one mistake, then it gets confused and a lot of other things are marked as errors as well. Okay, get rid of that comma. So the first part of that is the namespace. The second part of that is the class in which this WriteLine method is contained. So what is a namespace? Provides a way to group similar classes. You can put a whole bunch of different classes in the same namespace. We could go and create another class and it would still be part of the same namespace. If I went over here and did add new, right? Then when I added a new class, a new item, then it would share the same namespace. If it didn't, then we would have to take that into account when we were calling the methods in that namespace, in that class. Since all of these things are going to be inside the same namespace, I'm not going to have to prefix them with the name of the namespace, although I conceivably could. Don't do this. I'm going to delete immediately. But lecture C#A dot, and then this is the name of my class, dot, and then there's a main method, right? And then I'd have to pass in something like that, right? So this is being the most specific way of calling that function. This is an error because I'm not passing in any arguments. Or since we're already in that namespace, I could leave that out. Since we're already in that class, we could leave that out too. Kind of like if you're telling somebody where you live. If you're talking to somebody else who lives in Oklahoma, you might not mention that you live in Oklahoma, right? If you ask me where I live, I might just say 123 South Main, assuming that you know that I live, in Midwest City because that's where we're sitting, and that I live in Oklahoma. But if I was in New York City, I'd probably start specifying those things, right? I live in Oklahoma, and I live in a certain town there. So the method header is everything on the first line. It includes the method name and what you will pass into and what will be returned from a method. Now, you Python programmers are familiar with the idea of giving a function name and then an optional list of arguments, but you did not have to declare a return type. You Java and C++ programmers are used to that idea. You do have to specify what it's going to return, if anything. But if it says void, it's not going to return anything. So there's no return statement at the bottom. You could tack one on, but it's not going to return any data. A lot of functions, a lot of methods you write will return something, right? That's why you're calling them, to do some kind of calculation, or it needs to return some kind of success or failure code to indicate that it worked. So a lot of the time we're not going to declare something as void. But in this case we are. Let's add another method to our class. We could even move these things to that method. I'm going to come up here and I'm going to do static void because it's not going to return anything. And what are we going to call our method? Say hello, because that's all it does. Parentheses in parentheses. That's the header. That's the method header. In other programming languages, I would not have capitalized that, but that's the standard for C#. Microsoft says so. It'll still work if you don't. And then after the method header, you put your curly brace and you put your code. Why don't we cut those two lines? You see me, I use keyboard shortcuts all the time, so all I did is I moved my cursor to the beginning of the line and then hold the shift key and then hit the down arrow a couple of times and I highlighted those lines. And then I did Control X, or I'm going to cut it. Of course, you can do everything with the mouse if you prefer. The first Mac didn't even have cursor keys because you were supposed to, back in 1984, Steve Jobs said that you were supposed to use the mouse the whole time. Of course, everybody likes cursor keys as well as mice, so that was fixed pretty fast. There we go. Now my program's not going to do a dang thing. No longer going to say hello, friend. So when I run it, boom, didn't do anything. Why? Because I moved that code into a method, but I did not call that method. So down here, I need to put a reference to it. Now again, I could do the whole shebang. I could do lecture C# dot lecture A dot say hello, but since we are already in that namespace and in that class, I can just call say hello parentheses in parentheses. I did not have to put anything between the parentheses because there was no parameters defined up here. So I did not have to pass any arguments. Arguments are what you put between the parentheses when you're calling the method, and parameters are what receives those arguments. Long name for those are parameter variables. Now I could make it so that we could pass in a variable. Why don't we get a little bit fancy and pass in a name? So we could declare a string and pass in the name. Right here in our method header, why don't we make string space name? Not with two N's. My keyboard likes to repeat keys. So you see that? I added that between the parentheses. And instead of writing out friend, I'm going to write out name without quotes. I'm going to write out the contents of the name parameter variable. Whoops, well that caused an error here. Well, that's because up here I now have an argument that needs to be filled in with data. I have two choices about how to fix that. One is I could provide a default value for name. And I'm going to undo this. My default name is Fred. Right? And now every time I run it, it's going to say hello Fred. And I'm going to undo that. I want to actually pass in the data. Yeah, notice it didn't even actually wait for me to see the output. It's just like in C++ where we were using system pause at the end. I'm going to delete my default value, and I'm going to pass it in as an argument. There. So the way you can pause C#, unlike C++, is just by calling an input statement, right? Ask for something but don't even store its result. And there are other ways of doing it, but we could use read key in order to ask, just to sit there and wait for them to do something. Let's give that a try. After we do say hello, we could do a print, right? Console.write line parentheses, hit enter to exit, end quote, end parentheses. And now we're going to read a key. We're going to wait for them to hit enter. So console.read key, or just read would also work, like that. Now when I run it, we ought to be good to go. Hello Fred, hit enter to exit. I think from now on I may even be leaving that line out. Right. It'll just say hello Fred. I don't know. Doesn't take that long to add it, did it? And then when I hit enter, it goes away. Hi, how you doing, Denise?
Not too bad. Is console.read a good way to do it to pause?
Yep, .read would work just as well. .read key would allow you to exit with any key, right? Spacebar would do it. Okay. .read makes them hit enter. So that's actually better. It takes fewer keystrokes to type. I told them to hit enter, so why not? You'll want to review the beginning of the video to catch back up. So this is the method header. Gives a name to the so-called method, the function, and this is the method body. This language does not have the concept of a prototype, unlike C++. It is not order dependent. You don't have to have the methods declared above where they're going to be invoked. If I had, don't bother doing that. I'm going to undo it. But if I put that below it, it would have worked just as well. Unlike Python, unlike C++. Java is like that though. You can put the methods in any order you want inside the class. It figures it out. Notice that this says that there's one reference to the function, and that's true. We have one reference to the say hello function. If we called it again, we wanted to say hello to somebody else, say hello, to Barney, end quote, end parentheses, semicolon. Hello Fred, hello Barney. Now we have two references to it. If I click that, does it highlight them? No, but it tells me where they are. That's kind of cool. It says show on code map. What's a code map? Alright, so there's say hello and then there's main. As I add more functions, we would see them listed inside our class. I'm surprised that it doesn't show them being broken up into, by the class and in the lecture. Excuse me, the namespace. We'll play with that. Why did we have to put static here? What does that mean? Static means that you do not have to have an object in order to invoke that method. We did not have to create a console object before we wrote to the screen. That's because these functions, these methods are declared as so-called static. If we had left that keyword out, then these would no longer work, and we would have to create a lecture object in order to use them. Now I'm going to do that, and then I'm going to undo it. So don't waste your time typing along, but since I took the word static off that function, off that method, see there? In order to invoke it, I would have to create an object of type lecture. I'd have to do, lecture A, whatever I'm going to call it, LA. And then I could call, LA dot say hello. Wilma, right? I'm going to undo that because that's doing unnecessary work. Since this is not defined as static, it is an instance method, meaning that you have to have an instance of the class in order to invoke it. And let's undo all that. Normally inside your main class, your so-called main, I'm calling it your so-called main class, but it's the one that's got the main method in it. You'll probably make all the methods you put in that specific class as static. Let me hit undo a couple of times to undo all those changes. Control Z, Control Z, Control Z. There we go. Now we're back. So what is white space? Remember in Python where you had to break things up into, precisely tab things over and not have things go on the next line except under certain circumstances? Well, here we don't have to do that. We could be idiots and do this. Right. All right. Now I'm cooking. Okay, that looks absolutely idiotic because it is, but it would work. I could build it and run it and it would behave just the same as it did before. Why don't I undo those changes? If you mess your code up like that though, if your things aren't lined up, it's hard to read. I would prefer you to take some effort to indent things appropriately, even though it's not strictly necessary, unlike Python. Well, how can you fix that? You could come up to Edit, Advanced, Format Document, and boom, it rearranges it. Makes it pretty. It didn't totally fix it right. It left this part way down here, but it made a good shot at it. Quite often you'll get to the point where you've accidentally typed too many of those guys, then it'll no longer run, or to where you don't have enough of those. So what I usually do, although I don't remember to do it every lecture, but I would certainly do so if I was doing professional programming, is add a comment to the closing brace. This is the end of the main method. This is the end of the class. I'd actually have to scroll up here and see what it is, but I could just do end class, right? And then do end namespace. So if I had too many opening braces, not enough closing braces, let me see what happens when I advance format document like that. Oh, it's trying to be pretty smart, but it's certainly not going to run correctly. It can help you figure out what's going on, right? Whether you have too many, closing braces or opening braces or whatever. In this case, the compiler's being pretty nice. It's telling you that we needed an extra closing brace. And we go there and we go, no, this is looking real good. I'm not going to need an extra closing brace there, so you're going to keep scrolling up until you find where it does, right? Because if you just tacked on another one of those, well, that doesn't look right. All right. Namespace should have been the bottom one. So there's an access modifier for every method. Public, private, protected, or internal. Public means that it can be called outside of the code. Private means that it can be outside of the class. Private means that it could be only called inside the class. Looks like you don't even have to put that. But I could have put in public static void. That would mean that this method is accessible outside of the Lecture A class. I wouldn't mind if you went ahead and put the access modifier on every one of your methods. But since you can leave them out, you don't got to do it. In this case, public or private will work because all of our code is inside the same class. Protected, well, we'll get to the different ones. Don't need to teach the whole book in the first chapter. So what is a keyword? Keywords are just the words that make up the language. There are not very many keywords in our program so far. They're all highlighted as blue right now, at least since I'm using a white on black, version. If you're using, since I'm using, black on white, your colors may be different. These are all the keywords. Those are the things that define the language. All the other words are identifiers that we either created or that the people who created C#, right? So write is a method that the developers of C#, that Microsoft created. That's why it's not blue. It's not a keyword. It's a method. And so the editor does try to colorize things to make it easy to spot, right? To figure out where everything is. So that's a class name. Colorizes those like that, right? What about the namespace? How does it colorize the namespace? Back when it was called Lecture C#A, Lecture C#A dot. Is that fixed? Oh wait, what am I doing? That's not part of that class. System.console.write. Okay, so the namespaces are not colorized in the same fashion. You can go into the settings and pick whatever colors you like to make things more readable. If you think that green comments are hard to read, you can change them. So selecting identifiers. You cannot begin, what's an identifier? It's a method name or a class name or a variable name. They can begin with an underscore. They can begin with an @, unlike C++ or Java. Or they can begin with a letter. And letters include foreign language letters. That's good news, except my keyboard only produces, English letters. So I have a variable here. That is a good variable name. We could add some comments as to what are valid identifiers. Maybe I'll just scroll down to the bottom of the code. Valid identifiers, variable names, etc. Letters, digits, underscores, and that @. Can you even use the @ in the middle of a variable? I've never tried that. If I created a variable called int I @x = 3, that looks crazy. Okay. It got rid of that. And what if I put that at the beginning, just like they said I could do? What do you know, that works. I've never paid much attention to that. All right, I'm going to get rid of that @ sign. All right, so valid identifiers consist of letters, digits, or underscores, but they cannot begin with a digit, but can include @. And I'm sure that that implies something very specific. Okay, instead of include, but can begin with @. How about $, which works in C++? Int $C. Nope. $, means something very specific. Not that I ever encouraged anybody to use $signs in C++ either, but in BASIC, that's how you declared your string variables. Variable names cannot be a reserved keyword. I cannot call a variable if or for or while, right? Int while. Nah. See, it even lit it up with a different color, you know. Our variable name should have been black by the time we were done with it. I'm going to create a variable called A. Just to leave it there. Or I is a good variable name. Or why not call it age? We might ask the user for their age. So selecting identifiers. These are all, why do I have this down here? Just distracting everybody. There's a lot of keywords. You cannot use these keywords as your variable name. Now, it's quite likely that you'll never want to create a variable called this or event or protected or whatever, but the compiler will let you know if you did. It won't be a mystery. So selecting identifiers. If it's a class name, they want you to begin it with an uppercase letter. If it's a method name, they want you to begin it with an uppercase letter in this language, unlike Java. If it's a variable, they want you to begin it with a lowercase letter. You'll see that I followed those guidelines, right? This was a variable name, so it's a lowercase letter. That's a variable name, lowercase letter. Age is a variable name, it's a lowercase letter. The methods start with a cap. The classes start with a cap. The namespace start with a cap. That's just by convention. So adding program comments, what's a comment? We know what a comment is. It's something that the compiler ignores, right? You can put anything you want in a comment and it'll get ignored, right? If I wrote class A and tried to define my class right there, that is not actually part of the code. It's like it gets deleted as soon as it's compiled. It certainly is not part of the program. So what do you use comments for? You just document what your code is doing. Two kinds of comments. That's a single line comment. And this, if you do /* is a multi-line comment. And you end that with a */ with no spaces. So that's good for comment blocks. You're going to type in several lines. Do it that way rather than take the time to enter // in front of them. Now when I'm adding things to the code, you know, to provide notes or whatever, I may not remember to make it a multi-line comment. So there are line comments, there are block comments, and then there are XML documentation format comments, which hopefully they will give you an example of because I do not offhand remember the specific syntax. So this program is written to demonstrate using comments, multi-line comment. The next line writes the message. That's a single line comment. Notice they're doing the same thing I did. End of main and end of class with one executing line. It's not in a namespace, but then I would have tacked on one more comment to indicate the end of the namespace. So steps for viewing a program's output. When you compile your code, it doesn't create an executable like in C++. It's more like Java. Remember I said that C# is Microsoft's answer to Java after they got sued by Sun. Gets compiled into an intermediate language. And then that intermediate language is run by the so-called just-in-time compiler. So every time you run a C# program, it's invoking a just-in-time compiler. That's just like Python programs. Python scripts require the Python runtime engine to run, and Java programs require the Java runtime engine to do. So you can compile from the command line, which I'm not going to do, or through the IDE, Visual Studio. Compiling from the command prompt. Yeah, skip that. The advantages of using Visual Studio. It's way easier. Okay, next page. All right, there are some specific ones. Code is displayed in color. It's called syntax highlighting. Some syntax errors are caught as you type. Right, if it underlines something in red right away, you know it's bad news. You can double click the error message and the cursor blips right up to the point. And it's got a whole bunch of debugging tools built into it. Whereas if you were just writing this stuff in a text file and then running it, you would not have all those debug tools. So you do it. Go to the command prompt. No thanks. All right. You do it. Compiling and executing a program using Visual Studio. Yeah, create a new project. That's going to be our C# console application. Enter a project name. Write your program using the editor. All it has to do is be some of those, system.console.write print statements. You click Build on the menu bar, and then click Build Solution. Or you can just click F6, or you can just run up there and click the start. It'll auto-compile for you at that time. Auto-build it, I should say. I'll use the term compile even when it's not strictly true, because it is sort of compiling. It's creating the intermediate language file. Then you debug on the menu bar and choose Start without debugging. Now honestly, I wasn't doing that, so it has been running with debugging. Not much harm in that, right? But if you come under debug, you can also start without debugging. What's the difference? With debugging, you can do something called setting a breakpoint. A breakpoint looks like this. Come over here and click on that. That means that when the program's running, when it reaches this point, it's going to stop. And so if I start it with debugging, why don't I set the breakpoint on the second line so that we'll see it print hello, but not the name? Or why don't we set the breakpoint on calling of it Barney? All right, so when I run it with debugging, it does part of it, right? It printed hello Fred, but it didn't get to print hello Barney because it's paused at that point. Why would you want to pause it at that point? You're in the debugger now. You can see the value of variables like args. It's actually null. There's no value for it. Age hasn't even been created yet. But you can watch it go line by line. I'm not going to do anything else with the debugger. But if I had chosen to start it without debugging, it would have just done the whole thing without pausing. Now, since that green button is sitting there so easy to click, I'm usually going to start my program with debugging. If you want to remove your breakpoint, you just click on that, it goes away. Alrighty, we're done with the chapter. How about that? We did it in less than an hour. But we need to do a little bit more than that. We want to be able to ask the user for a value and do something with it. Like we want to ask them for their age. We're going to use .read for that. Let's tell them that we want their age though. I really thought that you could just type in CW tab or O system CW tab. There was some way to get it to auto-fill out the entire console.write line with the 3 keystrokes. I don't remember it. So console.write parentheses quote, what is your age, question mark. And I like to put a greater than sign where they're supposed to type in their input. So before the closing quote, after the question mark, I'm putting the greater than, end quote, end parentheses, semicolon. And that'll let them type in their age. Well, not yet, because we don't have a read statement. Age equals console dot read. Why do I have the feeling it's not going to be that easy? Isn't going to be that easy. I think I'm thinking of Java, where you have to do next int versus next float versus next string versus next double. All right. Let's do something with that age. Like, let's add 2 to it, right? We could do age equals age plus 2, or age plus equals 2. How about we do it old school? Age equals age plus 2, and then we're going to print a message out. So I want to write out there that this is going to be their age in a couple of years. Console dot. Now you may remember from Java or something like that you have a printf in those languages to differentiate it from the other style of print. Well, not in this one. You just call dot write, but you can create your placeholders right then and there. So console dot write. How about write line? Just go to the next line at the end of it. Console dot write line, capital L. Inside the quotes, we're going to say, in 2 years, comma, you will be, kind of run out of space because my font is so big. So here's how you do the placeholders in this language. Curly brace. 0 is the first placeholder. 1 would be the second. 2 would be the third. Like that. You will be angle 0, end angle, years old. Not angles, curly brace. 0, end curly brace, years old. End quote. Now we need to pass in an argument to fill in that placeholder. I just want to print out age, comma, age. Oh, now I've got things out of order, right? Do I really want hit enter to exit to be above these things? Not really. If you want to really impress your friends, then you can highlight some text, grab it, and pull it down. That always messes up for me and looks goofy anyway, so I'm just going to cut and paste it like always. All right, what's your age? I'm 90. And it went ahead and closed it, even though all right, I'm slightly miffed by that. Excuse me for a moment. All right, I had forgotten. The reason the book tells you to run it without debugging is because it pauses the output. What's happening here is that for some reason when I hit the enter key, maybe if I'd done read line, it would not have gone on to the next, it would not have closed the window. I'm going to try that, but then I'm going to show you the difference between running with debugging and running without. Nope. All right, so fine. I may not even put that stuff at the bottom of my program anymore. From now on, I'm just going to do, when I'm ready to test it, start without debugging, and then it will not close the window when it's done running. Now to me, it ought to be the opposite. If you're debugging, you kind of want to see the result at the, well, I didn't make it up, so that's the case.
You typed in 67 and it says in 2 years you're going to be 56.
That reminds you insane.
Yeah. So mine defaults to 51 for some reason.
Yeah, it's being pointed out that the numbers are incorrect. Right, if I type in that I'm 100, oh, for Pete's sake. What's the keyboard shortcut for doing that? F6? Oh, and F6 didn't work. Probably the monitor is intercepting that or something. All right. Oh, it's Control F5. What's your age? I'm 100. It's probably the ASCII value of the number. I think that's the case.
Yeah, because console.read reads the next character.
Right, console.read reads the next character, so it's storing the ASCII value of the first character typed in. My mistake. So this is actually going to take a few more steps, but if you recall, if you've done Python, after you get some input, you then have to convert it into an integer or a float or whatever in order to actually do math with it. What's going on here is that .read is accepting only a single character, and it's storing the ASCII value of the number that you typed in. I believe that to be the case. So we're going to actually have to read it in as a string and then parse it to convert it into be a number. So this line here is completely wrong. I'm going to delete age equals console.read. I'm going to declare a string for my input. String space s. S is good enough. It's a lame variable name, but if I wanted to be really fancy, I could call it sAge, right, to indicate that I'm going to be storing the age in that variable. But I don't mind just calling it s for this simple of a program. S is equal to console.readLine, parentheses in parentheses, and now I have to parse it. Have to convert it into an int. Age, let me look at my cheat sheet real fast. Int 32. Age equals I, capital I, int. Notice that we have a whole bunch of different options here. You want to turn it into a 64, which is like a C++'s long. But I just want to do a 32, a regular int. Int 32 dot parse parentheses s in parentheses semicolon. Now to work. I am real glad that you noticed that it was providing an incorrect output. All right, now it's working. All right, so there's the entirety of our program. Well, almost, right? It doesn't have the main method. So if you need to ogle it, take a look. I'm going to scroll up to here, pause your recording. Right? I could shrink it a little. There, that's the entirety of the program. If you entered this, great. If you didn't, that's fine. For your lectures, I don't require you to take screenshots and upload them, but I want to go ahead and demonstrate it just this time. So if you're on a Windows unit, I'm going to show you how to do the screenshot. If you're on a Mac, you can figure it out. It's just as easy. You press a certain key and it saves it right to the desktop. Even easier than this. So if I was going to take a screenshot, which I do want you to do on your homework, I would hit the print screen button, which is next to the rightmost function key. You might have to hit some kind of modifier to get to it if you're using a laptop. So I just hit that button, and then I'm going to paste it into a Word document or a Paint doc. And you folks who are in the lecture right now don't have to do this, and even those of y'all at home don't actually have to do this. So now I'm in Paint, and I'm going to hit Control V to paste, or however you like to paste. Now I have a screenshot. You don't have to take the time to crop it and make it look pretty. Just save it. Save it as, Lecture A. We should have a nice folder for all of our homework submissions, right? So C# Lecture A, I'm going to call it that. Put my initials on it and everything. Just to be really nice. Okay. There we go. Now I have a screenshot that I could submit along with the rest of the code. So for your homework, what do I want you to do? For the lectures, I want you to upload the .cs file or the entire project if you want, and a lecture video review saying, what you learned. If you attended the lecture, you don't have to fill out the lecture video review. You can just fill out the lecture video review without doing, typing along with the code. Some people find it difficult to type along with the code. I have sympathy, so you don't gotta. So we need to have a Dropbox to submit our code to, and we need to be able to upload it. What I'm going to do is, now that we're done, I'm going to go ahead and close my Visual Studio project to make sure that everything is saved to disk. Right? Close solution. Then I'm going to go and find that solution and zip it. Now for me, it's in the Documents folder. Documents, Visual Studio, Projects, Lecture C#A. That's it. I'm just going to right click it and do send to. Oh, I guess people won't be doing this on the Mac. Well, I guess it's possible they could install, Parallels Desktop or Boot Camp or something. Send to zip file, compressed zip folder. That's what you ought to upload. Or just go and find the .cs file. That's cool too, but if you give me the entire project, I can open the entire project and test it really quickly. If you give me only that, then I kind of have to already have a project and copy and paste some code and do some stuff like that. So I would rather you give me the zip of the project. Now that makes a pretty good, big program because it includes all this stuff in the debug bin directory, but nowadays space is not such a big thing. If you're uploading with a 96K dial-up modem, you would care and want to delete all that. All right, we need a Dropbox. All right, so we're ready to upload our file. This may be your first semester here, or maybe your first time using Canvas, so I'm going to go ahead and demo it. What we need to do is go to Modules. We need to find the lecture. It'll have a slightly different name. It'll say Lecture A Upload. You're going to click Submit Assignment. And you're going to choose your lecture video form, review form, and the .zip file. Well, where's the lecture review form? Ought to be up in class information. Right, lecture video form. So you're going to want to fill that out. Make the zip file if you're going to upload it. Save this one, and then upload them both. So Modules, Lecture A, Submit Assignment, choose a file. I'm going to go and find that zip file in my Visual Studio projects. Or I could go and find the CS file specifically. Zip file is good enough. Also, add another file and choose the video review form, which I did not fill out, so I think I'll just upload my my screenshot if you took one, and submit the assignment. Alright, so we're going to need some homework based on this concept. It's going to be pretty easy, but I want you to be able to print, and I want you to be able to do some input and output. Well, I guess printing is input and output. You don't have to create any methods. It can be as simple as possible. But here's what I want you to do. Be real easy. Ask the user to enter two values, x and y. Just make them ints. And then calculate x plus y, x minus y, and x times y. We could even do x divided by y, but it would be doing integer math. Might blow up if they typed in 0 for y. That's good enough. And then display the results. Look at the code for an example of doing integer input. Use console.readline and int32 dot. Was it just parse int, or did it have the whole word parse integer? Ooh, if I hadn't closed it, I'd be able to tell. Oh, it's just parse without the times, slipping back into Java again. All right, so integer int.32 parse. There we go. All right, that makes sense, gang? First program ought to be pretty easy since we have a good example based on what we did. And I'll include the source code. Right. Are we all good? Alrighty. I hope I resumed it before doing all that stuff at the end. It's always exciting to find out. Yep, I did.